All right, so today's lesson we're looking at topic 7, stable structures. So what does it mean to be stable? That means its ability to maintain shape and position. So to design stable structures, so structures that are less likely to tip, engineers, they need to know what features of a leaning object determine whether it will tip over or stay balanced. So balancing act. Just some points here on balancing and looking at these structures here and why don't they fall over. So we know that if objects are resting on a large area and have most of their mass closer to the ground, they will be more stable. So engineers, they need to calculate exactly how large a foundation is necessary or the best place to put heavy heating and air conditioning machinery. They need to be able to design structures like aircraft and rockets. They have to be stable even when they aren't resting on the ground. So to make these precise calculations, they have to find this special point within a structure. It's called its center of gravity. So center of gravity, it's the point at which all of the gravitational force of an object may be considered to act. So the force of gravity is going to act directly on those points, and all objects, they have a center of gravity, and when an object falls, the center of gravity falls in a straight line, and all other points rotate around the center of gravity while the object falls. So in this diagram here, so we have this object here, force of gravity on the center of gravity, and then the person's finger is the force of the finger on the center of gravity. So when the force exerted by the finger is lined up with the force of gravity acting on the center of gravity, this object is balanced. So therefore it won't be tipping. Here, the force of gravity on the center of gravity is here, but the finger has been placed beside the center of gravity. So it's not supporting the center of gravity, so therefore it will tip and the object will begin to fall. I do have a short video here. So next we're looking at unbalanced structures. So to determine whether a structure is balanced or if it's going to fall, we would locate its center of gravity. Draw a line directly down towards Earth. If the arrow points to a solid foundation, the structure is balanced. That's what we see here. This is a chimney, and this is showing it's a stable structure. Here, if the arrow falls beside the foundation, the structure is not stable. That's what we see here. If the ground beneath a structure is uneven and unstable, the structure may tip. And here we see the shear stress developing right here. So the chimney here is unstable. It's going to tip or break apart because of the large shear forces shown there. Here we're just looking at some images here. We have a heavy mass acts as a counterweight to keep this crane stable. Here we have all these cables on this boat that keeps the masts stable. Here the sailors can act as a counterweight to balance that small boat. And then symmetrical structures can also balance gravitational forces around the center of gravity. A firm foundation is necessary for a stable structure. So solid ground, it's not always firm and stable, especially if it's moist. Water near the surface can freeze, it can expand in the winter, and that'll lift the ground. In warmer weather, the melted ice, water will start to drain away. It'll shift tiny soil particles and leave spaces that will collapse under pressure. Soil can compact, potholes can appear. Clay soil will act in the same way when they absorb water and when they dry out. Large sections of soil can slip sideways over moist soil layers underground, and that can cause sinkholes and landslides. And if the soil is very moist, it can start to flow like a thick liquid. So if builders don't obtain thorough studies of the ground, many homeowners can start to see cracks in their walls and their foundations. In this image here, this is showing a house that is collapsing into the North Saskatchewan River because the ground under the house was unstable. So many other homeowners back here are also worried of the stability of their homes. Okay, if there's an earthquake or something like that, the ground under their homes can become full of water. It could be unstable in an earthquake. So how do builders construct a stable structure on shifty ground? So there's these strategies here we'll talk about. There's 3 of them. They have to start by creating a firm foundation. This first one is finding something solid. So below the soil, we see solid bedrock. If the loose surface soil is not too deep, builders can dig it out completely, and then they can build a stable foundation directly on the bedrock. If the loose soil is too deep, they can sink these pilings. These are large metal, concrete, or wood cylinders. They sink it through the soil until it rests on the bedrock. Then the structure can be built so that its weight is carried by these pilings to the rock beneath. Let's see here. Many parts of Canada, foundation walls about 1.5 meters deep. They reach firm layers of soil that will give enough support. Another method is to make a solid layer. So for example, road builders, they will pack loose surface soil before paving to create a solid base for the asphalt or concrete. Later on, if the pavement starts to crack, repair crews, they'll dig out the soil and replace it with a packed layer of gravel. Then they'll repave on top of the more solid material. These packed gravel foundations are also useful for dams and other mass structures. So here we can see layers in the road base. Okay, so we have like large ground stones, then we have smaller broken stones, then we have the rough asphalt, and then the smooth asphalt on top. We can thirdly spread the load. So if the weight of a structure is spread over a large area, any particular part of the ground supports only a small part of the weight. So often buildings are constructed on many shallow pilings rather than on a few. Even if the pilings don't reach bedrock, the soil beneath each one is strong enough to carry its part of the load. This is why footings, the concrete foundation beneath house basement walls, are wider than the walls themselves. So spreading the weight of the walls over a large area reduces the stress on every part of the soil beneath them. All right, so here we see the footing. Here made of concrete, it's beneath the foundation wall. It will reduce the stress on the soil. Lastly is something called rapid rotation. If you've ever ride a bike, you know that it's harder to balance while moving slowly. The faster you're spinning the wheels, the more the bicycle resists being tipped. Also, if most of the mass of a wheel is located far from the center, the stability becomes even greater. Gyroscopes are devices with heavy outer rims. They can be built to spin tens of thousands of times per minute, and when balanced on its axle, it'll keep pointing in the same direction, even if the structure on which it is spinning will move or turn. So that's called spin stabilization. It's the principle shown by a gyroscope. It's useful for objects that aren't resting on a solid foundation. So like space satellites, they need to keep their antennas pointed back to Earth and their instruments facing the proper location in space. Football players, they want their ball to travel in a stable, predictable path. So they practice so that they can perfect these spiral throws or kicks. Yo-yos, frisbees, they also use that concept of spin stabilization. right? I have a couple videos here, so I'm going to pause here.